we're talking about, in this 9.3, special products of polynomials. We're starting off special products of polynomials. The essential question for us is going to be, how do we use the special product pattern to multiply polynomials? And we're going to start off with the square of a binomial pattern. Damien, you ready, buddy?
Yeah.
Okay, the square of a binomial pattern. I want to point out to you what the square part means here, okay? When it says the square, this part, that's referring to the exponent. The exponent is a 2. Whenever the exponent is a 2, we call that something squared. And then the binomial part is referring to the fact that this is a binomial here, right? This is a plus b. And the a and the b are just a generic, any old, regular binomial pattern. Okay? So, let me ask you the question then. What does the square actually mean to the a plus b? Now remember, I'm adding in there, not multiplying. So what does it actually mean to square a plus b? What does it literally mean? It means a plus b times a plus b. Yeah, it does not mean a squared plus b squared. That's not what it means, because we're not allowed to do that. We can only do that if we're multiplying the a and the b. Okay, very good. So check it out. We have an a plus b times a plus b. That's what the squared part means. That's what it tells us. Okay, do you notice anything about these two? They are the same. Good. What else do you notice? Yes, sir. They're both addition. Good. What else do you notice? What type of polynomials are there? They're two binomials. If you multiply two binomials, what should you use? We should use FOIL. All right, very good. So let's go ahead and do that. So if I use FOIL, let's go first. A times a. What's that going to give us, everybody? That's going to give us a squared, correct? So that's going to give us a squared. Very good. What does the O stand for? Outer. So A and B, right? Those are the outers. What's A times B? AB. Very good. Plus AB. I stands for what? Inner. Inner. Very good. So we're going to do the B and the A. So what's B times A? Okay, so plus BA. Very good. And then finally, L stands for last. What's B times B? B squared. Okay, now, are there any like terms? Yeah, the ba and the ah, right? Do you realize that those are like terms? Because they have the same variables, an a and an a, and the same exponents, right? And a b and a b. So how many ABs or BAs do you have? There's two of them, right? So that means this simplifies to a squared plus, how many ABs are there? 2AB, and then finally plus a b squared. Now, some people really don't like this part right here. Some people don't realize that that's the same, but let me prove it to you that it is, okay? If I asked you to multiply 7 times 2, let's call the a 7 and the b 2. Is that the same thing as 2 times 7? It is, right? No matter how you look at it, the answer is 14, right? And since you're multiplying those two numbers, those are considered like terms, but a lot of students don't recognize that they are, and I want you to make sure that you do. Okay, also, I want to show you another way to represent this. I'm going to show you a box method using two binomials. So check this out. I'm going to put a plus b up top, all right? And I'm going to put a plus b on the side. So how many squares should I have? 4, right? Okay, let's see here. What's a times a? A squared. What's a times b? AB. What's b times a? BA. And what's b times b? B squared. And check it out. If you still look at the diagonals, how many of those are there? There's 2, right? So it still works. So the goal here to understand is that whenever we have an a plus a b squared, it always becomes this, straight out here. Does that make sense? All right, good. Now, let's go a little bit faster with a minus b quantity squared. It literally means this. It literally means, a minus b times a minus b. Two binomials. The squared part means to multiply the entire term by itself. So we're going to use FOIL. That's going to give me a squared. First, outer is going to give me negative AB. Inner is going to give me another negative BA. And finally, last gives me a positive b squared. Anybody see any like terms here? Yeah, so I end up with a squared minus 2ab's plus b squared. Alright, so whenever, the goal here to remember, whenever we see an a minus a b squared, it's going to turn into this for the exact same reason. Now take a look at these. These are really similar, aren't they? Look how similar these are. What's the only difference? The only difference is a minus sign in front of that AB. Alright? Okay, let's practice with this. Let's do some examples. Are you guys following along? Is this cool? Yeah, you sure? You swear? You promise? Super rad? Okay, good. Let's do this. Let's do together x plus 4 quantity squared. Alright, x plus 4 quantity squared. Okay. Guess what the number one mistake that people make is? Guess what the number one mistake is? Yeah. They do x squared plus 4 squared. It's not equal to that. Do not be that person that does that. Don't be that one person. Guaranteed. On the test, there's going to be at least 3 of you out there that do that. Your goal is to not be that person. Okay? Do not be that person. So instead, we're going to do it the right way. We know that this is going to be x squared, okay, plus 2 times 4 times x plus 4 squared. Now, right, I know everyone's already freaking out. How did you do this so fast? I know. It happens every year. A plus b squared. Remember, it means a squared plus 2ab plus b squared. We just did it right above, correct? Okay, in this case, the a is represented by the x. True? You guys good with that part? The b is represented by the 4. So I'm going to have the a squared. There's my a squared. I'm going to have the number 2, whatever my a value is. My a is a 4. And my b is an x. And then finally, I'm going to have a b squared. So 4 squared. That's all I did. I didn't do anything scary or crazy. I just plugged in to what we had, to the formula. So let's simplify. This is going to be x squared. What's 2 times 4 times x? Very good. And what's 4 squared? Yeah, 16. There you go. You did 4 times 2, not 4 squared. Okay, let's do another one. Let's try this one. Let's do x minus 3 quantity squared. All right. Now, some people like to do this. Some people like to do this trick, okay? Whenever they have a binomial and they square it, some people do this. They say, okay, I take the first term. What's my first term? X, and I square it. All right? And then they leave a space. And they take the last term. What's the last term? Negative 3, and you square it. What do you get? No, what's a negative 3 squared, you guys? 9. Very good. Okay? Okay? Negative 3 times negative 3, positive 9. And then they leave a space in the middle. And then they just go negative 2 times the x times the 3. Now, people say, well, how come we didn't make the 3 negative? Well, because I know that this is a minus sign between them, and I know I have to have a minus sign here. That's what the rule says. So that gives me x squared minus 6x plus 9. Now, if you don't believe that, if you don't like that, then just do this. Just do x minus 3 times x minus 3 and use FOIL. Right? But there's a trick. I mean, if it's a binomial square, we can just skip straight to the formula. But it's okay with me if you do choose to do it this way. And if you use FOIL, you're going to get x squared minus 3x plus 9, which is just x squared minus 6x plus 9, which is that right there. I want you to understand that you get the same thing either way. You get the same thing either way. You guys with me on that part? Yeah, for sure. Okay, well, you guys try it on your own. All right, try this one. Please do try this. Let's do. Okay. All right, Josh, what'd you get, dude?
X squared plus 9x plus 9x plus 81.
He got x squared plus 9x. Ooh, plus 9x plus 81. Did you use the FOIL or did you use the... You just use FOIL? Okay. But you still have to realize that those are like terms. So x squared plus 18x plus 81. The other way to do it is to say x squared plus 2 times 9 times x plus 9 squared. Same exact thing, right? X squared plus 18x plus 81. However you want to do it. They end up being the same. Okay, now sometimes you get problems that look like this. Yep. Sometimes there are problems that look like this. Yep, not trying to, but just the way it happens. 2x plus 3, all squared. All right. Sometimes these come along, and we have to know how to deal with these. Okay, the rule still applies, but the only difference is now there's a coefficient attached to the first term. So when you square the first term, you actually have to square all of the first term. 2x squared. And then 2 times 2x times 3. And then finally 3 squared. So what students forget to do a lot of the times is they forget that 2 has to be tagged along with it there and there. Now remember, this is just the formula again. This is just, a plus b squared is just the first thing squared, 2 times the 2 middle terms, and then the last thing squared. It's the same formula over and over and over again. But in this case, the a has 2 terms or 2 parts to it. It has a 2 and an x. And a lot of students forget that part, so don't forget to do that part. So the right answer should be this. It should be 4x squared, because 2 squared is 4. Plus, let's see here, 2 times 2 is 4. 4 times 3 is 12. So this should be 12x. And then plus 9. So that's the answer I should get. Now, if you're not comfortable with that, and you just want to do 2x plus 3 times another 2x plus 3, because that's what the squared part means, and you use FOIL, notice you get 2x times 2x, that's your 4x squared. Then you get 2x times 3, that's your 6x. Another 2x times 3, that's another 6x. And finally, 3 times 3 is the 9. And those add together to give you the 12x. Do you guys see the similarities there? Okay. All right. Okay. That's it. We're done for the day for that part.